All right, continue from the previous video. The question gonna be, when do we draw the resonance structures, right? When do we draw the curved arrow and show multiple structures, right? That is when you see a conjugation. All right, let's take a look at the definition of conjugation real quick, okay? So the conjugation is the overlap of 3 or more p orbitals on adjacent atoms. Adjacent means next to each other. For example, so this carbon is adjacent to this carbon, and it also adjacent to a carbocation. Okay, so that's adjacent means next to each other. So the conjugation is the overlap of 3 or more p orbitals they are next to each other, right? If you look at this compound, do you see p orbitals next to each other though? Start with the 2 carbons on the left side, right? This guy are sp2 carbon. Of course, they got p orbitals on there, right? The question is, does the last carbon on the right have p orbitals or not? It does. Actually, it does, right? This is carbocation, got an empty p orbital. Let me show you here, right? So a regular carbon and sp3 carbon, they all are sp3. No p orbitals left, right? All 3 p orbitals are used to form sp3 orbitals. So there's no p orbital left. But in the case of carbocation, this guy only sp2, which means it got a p orbitals left right there, and it's empty, nothing on it. All right. So I'm going to put p orbital right here. This is going to go back to analogy that I gave you in the previous video in the container with water. So container with water, container with water, container without water. So in this case, the water will flow from the full one to the empty one. Look like that. Same thing with right here. So the container is actually the p orbital, right? We have 3 p orbital there. And the electrons right here will flow to the empty one. Ta-da. All right. So when you see the conjugation, that is when you draw resonance structures. Okay. You can't draw the resonance structures. All right. Try this one. Another example. A lone pair adjacent to a p orbitals are delocalized. Delocalized, it can move. All right. So it has conjugation here. Oh, let me show you. I'm sure you know by now there are p orbitals on an sp2 carbon right here on the double bond. Right. So there are p orbitals on them. And now, this guy right here doesn't have p orbitals. This is an sp3. But here's the thing. Here's what happened. All right, I'm going to show you this one, sp3. Right, look like a I'm trying to make a tetrahedral if you can try to see it. Okay, so there's a tetrahedral. Of course, the lone pair right here can't overlap with these two, as they are not conjugated for sure, right? The conjugation is going to be all p orbitals are parallel like that, right? That's a conjugation. So this lone pair, my point is right now, this lone pair is not conjugated, right, to the 2 p orbitals on here, all right? But here's what happened. This bond can rotate, right? This bond can rotate. Move the lone pair up right here to kind of parallel with the 2 p orbitals, and that is the conjugation, right? My point is, if you see a lone pair adjacent to a pi bond, it is delocalized, and it got a conjugation. They are conjugated. Okay, so you can draw the arrow. Let me show you real quick. So let's a little detail right here. I'm going to draw the arrow move from a lone pair to a bond. Okay, from double bond right here. But here's the thing: if I do that, the carbon in the middle would be over-octet. So I have to use another arrow, push this 2 electron on the pi electrons here to the carbon on the left side. Here we go. All right, there's a second type that common conjugation that you're gonna see. Right. All right. Let's summarize real quick. So this you have to be able to recognize the conjugation or conjugated pi system. All right. So you have to be able to find the pi bond basically. All right. Let's take a look here. So if you see a positive charge, which is carbocation, got a p orbitals in it. A positive charge adjacent to a double bond, that's those are conjugation. Okay. Negative charge next to double bond also conjugated, right? They are you can delocalize it. And a double bond, single, double. These 3 double bonds are conjugated because all carbon have p orbital, p orbital, p orbital, p orbital. All of them have p orbitals, right? Except this guy. This guy is not conjugated. This is sp3, no p orbitals there. Okay. So To answer the first question, when do you draw resonance structures? When you see the conjugation, which is the overlap of 3 or more p orbitals, all of them have to parallel, like line up nicely, single file. Okay. All right. Sometimes an sp3 carbon can break the conjugated pi system. Give you some example here. Start on the left side. You know by now all the sp2 carbon, the double bond, have p orbitals. So these are conjugated. Okay. If you see the picture down here, it shows the electron flow from the left carbon on the left side all the way to the fourth carbon. Right. So that's electron flow. If you look at the second structure on the right, okay, on the right side, these are sp2 carbon. Of course, they got p orbitals, but in the middle, and it is an sp3 carbon. This guy doesn't have p orbitals. Breaks the conjugation right then. Okay, so these are isolated double bond, not conjugated double bond. Okay, now you see electron flow between two carbon. The sp3 carbon in the middle is right here. Break the conjugation. All right. All right, you have to be able to recognize the conjugated pi system, right? Start with the first compound here. Okay, I'm sure you can see it now. sp2, 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 sp2. These 4 carbons got 1 p orbitals on it, right? So these are conjugated, right? The conjugated double bond. Now the second structure, right? sp2, sp3, sp2, sp2. So these 2 double bonds are not conjugated. They are non-conjugated. Yeah, sp3 breaks it in the middle. Okay, on the right side right here, this guy, so look at benzene ring over here, all of them are sp2. These are your conjugation. Yeah, so all 3 double bond, double, single, double, they are conjugated. Down here, what we got here, so all the double bonded carbon, you know, is sp2 now. In the middle, that's also carbocation, also got an sp2, is it an sp2, so which means that it also has a p orbitals. Like that, it's empty basically, but they are all conjugated. Okay, this compound right here. All right, so the conjugation just 1, 2, 3, 4. These 4 carbons here. All right, last one. Now we got, so all this double bonded carbon, sp2. Now the question in the middle, is this guy conjugated or not? Yes, conjugated, a lone pair next to double bond. Now you might ask, hold on, where's the lone pair? Well, if you still remember, the negative charge mean a lone pair. All right, there's a lone pair there. Although in sp3, but that lone pair can arrange itself, rotate around, make it conjugated to the double bonds. Okay, so a double bond. So a lone pair next to a double bond are delocalized or conjugated. They can move. All right. Okay. All right. Let's go to the next video.